press the bell icon on the YouTube app and never miss another update.
Hello students, in the last class we discussed the definition of the derivatives as well as first principle method. In the first principle we already discussed one formula, correct? The formula, very important formula. So if y is equal to x to the power n, if y is equal to x to the power n, dy by dx n into x to the power n minus 1. This is the first formula we discussed in the last class. And one more formula we discussed, the derivative of constant. If y is equal to constant, then dy by dx is 0. The derivative of constant function, is 0, correct? The derivative of constant function is 0. So we discussed these two formulas in the last class, as well as we know the definition of the derivative, okay, and differentiation means the process of finding the derivative. Derivative means, in the mathematical manner, if I say derivative means limit h tends to 0, f of x plus h minus f of x divided by h. If this limit exists, then that limit we call it as derivative of the given function. In the geometrical manner, if I want to say rate of change of quantity with respect to the variable. Yes, rate of change of quantity with respect to the variable. So today we discuss the same concept of the derivative of first principle for trigonometric functions. So first principle for trigonometric functions. This is a very important one. Trigonometric functions means derivative of sin x, derivative of cos x, derivative of tan x, derivative of cot x, derivative of cosecant x, and derivative of secant x. That we don't know. One by one we discuss. So first principle for what? Trigonometric function, and this concept is very important for annual examination. So the first formula, f of x is equal to sin x. F of x is equal to sin x. That means now I am finding the derivative of what? Sin x. F of x is equal to sin x. So one more result that we want, sin of x plus h. What I do here? Replace x divided by what? X plus h, correct? Replace x divided by what? X plus h. So write the formula, first principle method formula. We know that. So f dash of x is equal to limit h tends to 0, f of x plus h minus f of x divided by h. Limit h tends to 0, f of x plus h minus f of x divided by h. So substitute here. That is equal to limit h tends to 0, sin of x plus h minus sin x divided by h. Sin of x plus h minus sin x divided by h. So firstly, if you want to substitute wherever h is 0, 0 by 0, sin x get cancelled. Again what we got? 0 by 0 indeterminate form. Then how to solve this one? Okay, so observe here, this complete term, this term, these two terms, this I call it as C and this I call it as D. Okay, you know the transformation formula in trigonometry. Once again I write if you want, sin C minus sin D, 2 cos C plus D by 2 into sin C minus D by 2. 2 cos C plus D by 2 into sin C minus D by 2. So I write here, this term is C and this term is D. That is equal to limit h tends to 0, 2 cos C plus D, C is what? X plus h plus D is what? X divided by 2 into sin C minus D, C is what? X plus h, D is what? Minus x divided by 2 whole divided by h. See, observe here, x plus h I treated as C, x I treated as D, x plus h I treated as C, x plus h I treated as C, x I treated as D, 2 cos C plus D by 2 into sin C minus D by 2, C minus D by 2. Okay, that is equal to, I write here, limit h tends to 0, limit h tends to 0, 2 cos x plus x, 2x plus h by 2, correct? And observe here, plus x minus x get cancelled, sin h by 2 into h. For denominator what I do, multiply and divided by 2. Multiply and divided by 2. This 2 and this 2 get cancelled. Limit h tends to 0, cos 2x plus h by 2, cos 2x plus h by 2, sin h by 2, denominator h by 2 right here, no problem. Or say h by 2. Why I write here? This is one function, this is another function. I split it. Limit h tends to 0, cos 2x plus h by 2 into limit h tends to 0, sin h by 2, h by 2, sin h by 2, h by 2. This is what? 1. Why it is 1? So you know, since, right here, since limit theta tends to 0, sin theta divided by theta is equal to 1. Correct? Here it is h by 2, h by 2. Has h tends to 0, no doubt h by 2 also tends to 0. And right below, as h tends to 0, h by 2 also tends to 0. H by 2 also tends to 0. That's why this is 1. Okay, fine. Next. So we apply wherever h, we apply 0. that is equal to cos 2x plus 0 divided by 2 into 1. This is the reason. 2 get cancelled. Answer is cos x. Answer is cos x. Observe here. Answer is cos x. Then what is the conclusion? The derivative of sin x. Very important. The derivative of sin x is cos x. We write here once again. The derivative, one sentence I write. If therefore, if I write y, if y is equal to sin x, you remember third formula this is, if y is equal to sin x, then dy by dx is cos x. If y is equal to sin x, dy by dx is cos x. That means derivative of sin x is what? Cos x. See the complete explanation, and you also practice very well. If you practice very well, then only you are understanding. Otherwise, it is very difficult. See the result. So, we go for the next trigonometric function. Before that, watch carefully. Very important property. So, how I steps use, how I to solve. See one by one each step properly, and you write it. You write and practice it. Then only you are understanding perfectly. Next property. See this one first. Second trigonometric function. Cos x. F of x is equal to cos x. So we already find the first trigonometric function sin x. Derivative of sin x. Understand? Derivative of sin x is cos x. Correct? The second trigonometric function, same procedure we follow as usual, same method. So f of cos x plus h, wherever x, substitute x plus h, and we know that f dash of x limit h tends to 0, f of x plus h minus f of x divided by h. First principle method. So f dash of x limit h tends to 0, cos x plus h minus cos x whole divided by h, cos x plus h minus cos x whole divided by h. This complete value. So this value, it is C, this value, it is D. See, observe here, it is in the form of cos C minus cos D, correct? It is in the form of cos C and minus cos D. Once again, if you want to substitute wherever h is 0, here is 0, just simply cos x minus cos x, cos x get cancelled, numerator is 0, denominator is also 0. So it is in the form of 0 by 0, indeterminate form, correct? Okay. So what we do? We use cos C minus cos D, correct? We use cos C minus cos D. In the trigonometry, you already know this one, minus 2 sine C plus D by 2 into sine C minus D by 2. Transformation formula. In the transformation formula, you already know cos C minus cos D. Cos C minus cos D minus 2 sine C plus D by 2 into sine C minus D by 2. So that is equal to limit h tends to 0 minus 2 sine C plus D by 2 x plus h plus x divided by 2 into sine C minus D x plus h minus x divided by 2 whole divided by h C plus D by 2 C minus D by 2 whole divided by h. So that is equal to h tends to 0 minus 2 sine x plus x 2x plus h divided by 2 plus x minus x get cancelled sine h by 2 whole divided by h. Sine h by 2 whole divided by what? It is h. For that, what I do? Same procedure what I follow in the sin x. Multiply and divide by 2. 2, what? Get cancelled. That is equal to limit h tends to 0 minus sine 2x plus h by 2 into sine h by 2 sine h by 2. We separate two limits because it is in the form of f of x into g of x. Limit h tends to 0. If you want minus here, no problem. If you write outside, no problem. Minus sine 2x plus h by 2. 2x plus h by 2. Limit h tends to 0. Sine h by 2. Sine h by 2 by h by 2. Since it is 1. Why it is 1? Limit theta tends to 0. Sin theta by theta is equal to 1. Correct? Theta tends to 0. Sin theta by theta is equal to 1. And as h tends to 0, h by 2 also tends to 0 because 0 by 2 is what? 0. So that is equal to limit. Okay, so if you want I substitute the value and find out the result. Minus sine 2x plus 0 by 2 into 2 to get cancelled minus sine x minus sin x, minus sin x. Then what is the conclusion? Conclusion is very important result. Second result is very important. One more formula we derive. If y is equal to cos x, okay, if y is equal to what? Cos x, then derivative dy by dx minus sin x, very important result. Second formula, derivative of cos x is minus sin x. First formula, derivative of sin x is cos x, correct? Second one, derivative of cos x minus sin x. Observe this proof carefully. You practice it, then only it is very easy. Each steps carefully how to observe. It is a very important proof. So we discussed two formulas. First one is derivative of sin x is cos x. Derivative of cos x minus sin x. Third one, see this one carefully. Okay, sin is over, cos is over. Third trigonometric function, f of x is equal to tan x. Now we are finding what? Derivative of tan x. Same procedure what we follow in the previous two problems. F of x plus h, tan of x plus h. We know that f dash of x, limit h tends to 0, minus f of x whole divided by h. X tends to 0, minus f of x plus h minus f of x, f of x plus h minus f of x divided by h. Substitute here. That is equal to limit h tends to 0. In place of f of x plus h, tan of x plus h minus tan x divided by whole divided by h, tan of x plus h minus tan x whole divided by h. See, observe here, if I substitute wherever h, I substitute 0. Tan x minus tan x get cancelled, numerator is 0. Denominator 0, so it is in the form of 0 by 0 form. Correct? So, indeterminate form. Then how to solve this one? For sin and cos, we use sin c minus sin d, cos c minus cos d. Transformation formula, we know that. But Tan C minus tan D, that we don't know. Correct? Then how to solve this one? What I do here, limit h tends to 0. You know that tan theta we can return as sin theta by cos theta. Same procedure I follow. Tan x plus h sin of x plus h divided by cos of x plus h. Tan x plus h over. Understand? Observe carefully. Tan theta we write sin theta by cos theta. Same method. Tan of x plus h we write sin of x plus h. Correct? By cos of x plus h minus tan x sin x by cos x whole divided by h. Whole divided by h. Correct? This is first step. Okay, first step. Next step, what I do, I take LCM. Cos of x plus h into cos x. Observe here, very important. That is equal to limit h tends to 0. In the numerator, I take LCM cos x plus h into cos x. This h as it is. Cos x plus h into cos x. If I take LCM, what will happen? Sin x plus h, cos x plus h get cancelled into cos x minus sin x. Okay, cos x get cancelled, cos x plus h, cos x plus h. Correct? So sin x plus h into cos x minus sin x into cos x plus h. Okay, that we return as limit h tends to 0. We rearrange the terms. These two are lies in the denominator, we write like this, no problem. H into cos x plus h into cos x. Numerator sin x plus h into cos x minus I write first this one, no problem. 2 into 3 is 6, 3 into 2 is also 6, no problem. Result will not affected. Cos x plus h into sin x. Why I write like this? See the result carefully. So this x plus h term, that I call it as A. X plus h I call it as A. This only x I call it as B. Okay, then here also this is A. B. See, observe here, it is in the form of sin A cos B minus cos A sin B. Which formula? Compound angle formula. So we know that, you already know in the trigonometric, sin A cos B minus cos A sin B is equal to what? Sin A cos B minus cos A sin B is equal to sin of A minus B. Correct? Sin of A minus B, sin A cos B minus cos A sin B is equal to what? Sin of A minus B, that is equal to limit h tends to 0, denominator we write as it is, cos x plus h cos x into h, cos x plus h cos x into h, sin A cos B minus cos A sin B. A is what? Angle A is x plus h, correct? Angle A is what? X plus h. B is what? X. Sin of A minus B, sin of A is what? X plus h minus B is what? X over. So what happens here? Plus x minus x get cancelled. Limit h tends to 0. We rewrite the terms. Only sin h is present. Correct? One step we follow, one step we write. Okay. Sin h cos of x plus h into cos x into h, cos x into h. Okay. We rewrite this term. What we do, we split into two parts. Limit h tends to 0, 1 divided by cos x plus h into cos x into sin h divided by h. Both are same. This and this result both are same. This is f of x and this is g of x. Separate limit we apply. Limit h tends to 0, 1 divided by cos x plus h into cos x. One limit h tends to 0, sin h divided by h, sin h divided by h. What will happen? This is 1. Why it is 1? Limit theta tends to 0, theorem 2, sin theta by theta is equal to 1. Since limit theta tends to 0, equal to 1. Theta tends to 0, sin theta divided by theta is equal to 1. Wherever h substitute 0, 1 divided by cos x plus 0 into cos x into 1. Why it is 1? Right. X plus 0 is x. So 1 divided by cos x into cos x. 1 divided by what? Cos x into cos x is what? Cos square x. 1 divided by cos square x. So you know very well 1 by cos theta, reciprocal relation in trigonometry. 1 by cos theta is what? Secant theta. So 1 by cos square x is nothing but secant square x. One more formula. Derivative of tan x. Very important. Derivative of tan x is what? Secant square x. Therefore, if I write y, in the first class I told, if I write y, we write dy by dx. If I write f of x, we write f dash of x. Okay? If y is equal to tan x, very important formula, then dy by dx is what? Secant square x. If y is equal to what? Tan x. If y is equal to tan x, then dy by dx is what? Secant square x. Dy by dx is what? Secant square x. Observe this proof very carefully. This is very important. Third proof. So first, once again I told, first one, derivative of sin x is cos x. Second one, derivative of cos x is minus sin x. Third one, derivative of tan x is secant square x. Very important. Very important. Observe this proof carefully. You perfect it first. Okay, if you write 3 to 4 times, then only you are perfecting the proof. Each steps observe very carefully. Next, tan is over, sin is over, cos is over, tan is over. Third over, fourth one we take tan is over, we take cot x. Okay. So 3 we finish up. Fourth one, fourth trigonometric function, cot x. F of x is equal to cot x, means now we are finding the derivative of what? Cot x. Derivative of cot x. Put wherever x plus h. So the cot x becomes what? Cot of x plus h. Okay. First principle formula we know that. F dash of x f dash of x is limit h tends to 0 f of x plus h minus f of x divided by h. So that is equal to substitute all the values. In place of f of x plus h, we substitute cot x plus h. In place of f of x, we write cot x divided by h. Okay, substitute wherever h, substitute 0. What will happen? We will see. Cot x plus 0. Cot x plus 0 is what? Cot x minus cot x. Cot x get cancelled. Numerator is 0. H 0, denominator is 0. So what will happen? It is in the form of 0 by 0, indeterminate form. Correct? So what we see in the tan x, same procedure we have to follow. Why? We don't know cot C minus cos D. Correct? We know only two formulas. Sin C minus sin D, cos C minus cos D, sin C plus sin D, cos C plus cos D. But that we don't know. Tan C minus tan D. Okay. Cot C minus cot D. Okay. What I do here, cot theta we write cos theta by sin theta. Correct? Cot theta we write cos theta by sin theta. Same procedure I applied here. So limit h tends to 0 cot x plus h cos x plus h sin x plus h minus cos x by sin x whole divided by h. First step, what we follow the previous problem tan x, same procedure we follow. Okay, same procedure. Cos x plus h by sin x plus h minus cos x divided by sin x by h. What we do? We take LCM. I write here. H tends to 0. H tends to 0. The LCM is sin x plus h sin x. Correct? Sin x plus h into sin x. Denominator h. So what happens in the numerator? Cos x plus h cos x plus h sin x plus h sin x plus h get cancelled into sin x minus cos x sin x get cancelled into sin of x plus h sin of x plus h. Limit h tends to 0 sin x plus h into sin x. So numerator, first I write here cos x plus into sin x, I write sin x into cos x plus h. Both are same. 2 into 3 is 6. 3 into 2 is also 6. Minus this one as it is. Cos x cos x into sin x plus h. Observe this one. This is A. Correct? A. B. Here also A. B. Sin A cos B minus cos A sin B. We know that. Since sin A cos B minus cos A sin B is equal to what? Sin of A minus B. Correct? Sin of what? A minus B. That is limit h tends to 0. A is what? X. Observe here. A is what? X. B is what? X plus h. Sin of x minus whole divided by h into correct? Sin x plus h into sin x plus h, sin x. If I multiply by minus to this term, minus x plus x minus x get cancelled, plus into minus, minus h. Limit h tends to 0, sin of minus h, correct? Sin of minus h divided by x plus h sin x, sin x plus h into sin x. So you know in the trigonometry, sin of right here, sin of minus theta, you know in the trigonometry, sin of minus theta. Since sin of minus theta is what? Minus sin theta, correct? Sin of minus theta minus sin theta. So that implies limit h tends to 0, sin of minus h minus sin h into cos, sorry, not cos, sin x plus h into sin x, sin x plus h into sin x. We separate into two parts. Limit h tends to 0 minus sin h divided by h into 1 divided by x plus h into sin x. So it is in the form of f of x into what? G of x. Apply separate limit. Limit h tends to 0 minus sin h divided by h into limit h tends to 0 1 divided by sin of x plus h into sin x, sin of x plus h into sin x. This minus right outside, minus into, right once again, no problem. Limit h tends to 0 sin h by h into limit h tends to 0 1 divided by sin x plus h into sin x, x plus h into sin x. If you write direct, no problem. This limit theta tends to 0 sin theta by theta, it is 1. This is 1. Since limit theta tends to 0 sin theta by theta is equal to 1. That is equal to minus 1, because outside is minus is there, that's why I write outside, minus 1 into 1 divided by, wherever h, z, substitute 0, sin x into sin x, correct? Because sin x plus 0 is sin x. So that is equal to minus 1 divided by sin x into sin x is what? Sin square x minus cosecant square x, 1 by sin theta cosecant theta minus 1 divided by sin square x minus 1 divided by sin square x is what? Minus cosecant square x. Therefore, fourth formula, if y is equal to cot x, if y is equal to what? Cot x, then dy by dx minus what? Cosecant square x. If y is equal to cot x, dy by dx, derivative of cot x minus cosecant square x. 4 formula we finish up. Derivative of sin x is cos x. Derivative of cos x is minus sin x. Derivative of tan x is secant square x. Derivative of cot x is minus cosecant square x. See this theorem, see this proof. Then fifth one. So we take one more trigonometric function. Which one? Secant x. And the last one is cosecant x. Next one, f of x, secant x, f of x plus h is what? Secant x plus h. So we know the formula, we know that f dash of x limit h tends to 0, f of x plus h minus f of x divided by h. Substitute, same procedure what we follow in the previous problem. Limit h tends to 0, secant x plus h minus secant x whole divided by h. Correct? So if you substitute wherever h is 0, secant x minus secant x is 0, h is 0, 0 by 0, indeterminate form. Then how to solve this one? Secant theta we write it as 1 by cos theta. Correct? Limit h tends to 0. So this we written as 1 by cos x plus h minus secant x we written as 1 by cos x whole divided by h. Correct? Whole divided by h. What we do next? Take LCM. LCM is what? Cos x plus h into cos x. The LCM is limit h tends to 0. LCM is what? Cos x plus h into cos x. Numerator cos x plus h, cos x will get cancelled. Cos x into 1, cos x minus cos x get cancelled. Cos x plus h into 1 is cos x plus h whole divided by h. So we write once again, rewrite, that is equal to limit h tends to 0, h into cos x plus h into cos x. No problem. Cos x minus cos x plus h. This is C and this is D. What we follow in cos x? Cos C minus cos D. We know that. Cos C minus cos D minus 2 sin C plus D by 2 into sin C minus D by 2, correct? Minus 2 sin C plus D by 2 into sin C minus D by 2. Limit h tends to 0 minus 2 sin C is what? X plus h by 2 into sin x minus x plus h by 2, correct? X minus x plus h by 2 whole divided by this, right as it is, h into cos x plus h into cos x. Cos x plus h into cos x. So x plus x 2x, okay, limit h tends to 0 minus 2 sin x plus x 2x plus h by 2 into sine. Observe here, minus x plus x get cancelled. Plus into minus, minus h by 2 whole divided by h into cos x plus h into cos x. Cos x plus h into cos x. Sine of minus theta minus sine theta. Again that minus into minus is what? Plus. Sine of minus theta minus sine theta. So minus into minus, minus into minus, it becomes what? Plus. So we write that is equal to limit h tends to 0 to sine 2x plus h by 2 into sine h by 2 whole divided by cos x plus h into cos x. Right here h. We write since sine of minus theta minus sine theta. Correct? Sine of minus theta minus sine theta. In the denominator, multiply and divided by 2. This 2 get cancelled. What about this one? If you apply limit, it is 1. Correct? So we rewrite once again. Limit h tends to 0 sine 2x plus h by 2 whole divided by cos x plus h into cos x into sine h by 2 sine h by 2 into h by 2. Separate two limits. Separate into two limits. Limit h tends to 0 sine 2x plus h by 2 cos x plus h into cos x. One limit. Limit h tends to 0 sine h by 2 sine h by 2 by h by 2. This result is 1 because theta tends to 0. Theta tends to 0. Sine theta divided by theta is 1. Since limit theta tends to 0, sine theta by theta is equal to 1. And as h tends to 0, h by 2 also tends to 0. This result is 1. Wherever h, observe here, wherever h, substitute 0. Sine 2x plus 0 by 2 whole divided by cos x plus 0 into cos x. 2 get cancelled into 1 sine x divided by cos x into cos x. Sin theta by cos theta, sin theta by cos theta, tan theta, tan x into 1 by cos x secant x. One more formula. Therefore, if y is equal to secant x, if y is equal to secant x, then dy by dx secant x into tan x. If y is equal to fifth formula, fifth trigonometric function, if y is equal to secant x, if y is equal to secant x, then dy by dx, observe this one, dy by dx is secant x into tan x, or else tan x into secant x, both are sine. So 5 we finish up. First one is sin x, cos x, tan x, cot x, secant x. In the same manner, I given a homework. Which one? F of x is equal to cosecant x. Do it you only. Okay, do it. So I derive this formula cosecant x in the next class. Thank you.